Hello, welcome to this YouTube channel, welcome to this tutorial. This is the NFL Game Prediction Project, as you saw from the title. It is an AI-based project to predict NFL games. In this video, I'm going to go over how you can build it, all the steps. I'm assuming that you have some Python background, but I am going to break down as reasonably simply as I can each line. So let's not waste any time, let's get into it right now. So I'm going to make this Colab notebook available so that you can run the code for yourself and you can copy paste and do whatever you need to do, but I'm going to teach you it here. So first step in this process, and I've broken this into steps, is to import all the libraries that we need. If you've never used Colab before, it's really simple. You can just play these blocks of code and it runs for you. So it's pretty cool. It takes a little time for the runtime to begin, and then once that check mark's there, you're good to go. The data that I got for this data set for this project, I got it from this website here called nflsavant.com. Here you can download the data, and when you download it, this is what it looks like. You have various columns here: game ID, date, quarter, minute. These are play-by-play statistics. So as you can see, like, each description kind of talks about what the play was about. You have data on the number of yards that were gained, where they were on the field, the year, obviously, the formation, I mean, everything about the plays. And then I also have here the upcoming schedule. This is something that I created. This is what we're going to be predicting. So we're going to predict the winners of these games. This schedule is from week 5 of the NFL season, which already passed, obviously, so you can compare and see how accurate this was. Last I checked, it was about, I think, 70% accurate on the games. At least it was this week. So you can download these data sets here. I have some of the raw data in the drive you can use, and then the box scores that I used to train I got from this site here. So you can also go there if you want to grab box scores. The way that I grabbed them was literally going like this, and then right clicking and copy pasting them, and then putting them into a CSV file. So next, importing the files. If you don't know how to do it, you're going to click on this icon right here, and you're just going to drag and drop those files in after you download them, and you're going to right click them to get the path. So I can actually do that here. Why don't I do that, because I don't have them right now. So you can follow these links and do what I'm doing. So I'm going to download this, and in this specific project I used the 2022 data and the 2023 data. And the reason I did that was because at that point in the season, week 5, there wasn't that much data on the teams. There was only 4 games. So I decided to get some more data from the other seasons. But as you can imagine, the shortcoming of that is things change from one season to another. Some players are traded and stuff. So it's not totally accurate. But now, today is November 2nd. So now there's, I think it's week 9 or something like that, 8. Something like that, but there's more data, so maybe you could train this just on the 2023 data and it might be even more accurate. That's what I would suspect. So there's a lot of potential for this project. So now that all our data is downloaded, we can drag and drop them into here. So as you can see, the data is already cleaned, and that really was the hardest, the most complicated part to get everything working, was to get the data cleaned first. And the reason is that this 2023 data at the time had a different date format, the team names were in a different format, I believe, as well. Yeah, everything was in a different format, and it required me to go through and change that. So I have the steps here to do that if you wanted to do that yourself, if you wanted to clean the data, but you don't have to, because the data I provided has it done already. This code in this specific section doesn't run because some of the variable names are different, but you can always go through and update that. But it's pretty simple. You just have to change the date format, change the scores data to use abbreviations, because the scores data, which is let me pull that up for you. So the scores data that I just copy pasted from that website has the full team names here. So you'd have to change that to the abbreviations. That's the second step of that data cleaning process. And then copying the scores to the play-by-play data. That way, all the scores were attached to those games. That way, later on when we were processing the data, it would be a little bit easier. And then I added a column called home 1, which is just a binary 1 or 0, or true or false if the team won or lost, the home team. So that's good, that's simple. Once that's done, we can move on to step 3. But if you guys want more information on how to clean the data and prepare it, let me know and I'll dedicate more time to that. So anyway, we want to start off with the offensive features. So these names should be the same. You shouldn't have to change this, but if you do, you would change. So this line of code here is where you read the data file and you read it into this variable, right? It's called a data frame. That's the type of variable it is. And but this is the link to it. So I'm going to assume from now on that you know a little bit about pandas and stuff like that. So anyway, we're going to get those two pieces of data from 2022 and 2023, and then we get the upcoming schedule, and we're going to hold that in this upcoming games data frame. So after that, we're going to combine the data from 2022 and 2023. So then we begin calculating the offensive features. So offensive features are just different metrics of the offensive side of the ball that can be indicative of wins and losses. So in this, we have three features, and actually the second one was a mistake on my part. It actually should be a defensive feature, but we have the average points scored. So the points that your team is able to score when they're home or as a visitor. Points allowed is how many points this team allows the other team to score. Again, that should have been defensive. And then this is just part of calculating the overall average points scored, home and away together. But these are the two features: points scored, points allowed, and then win rate. And that's the total number of wins for the home and the visitor teams. So again, we just group the data by the home teams, and then we get the if the home team won, that column that I spoke about before, and then we get the sum of that. Visitor wins, we do a similar thing. We just have a lambda function here, just subtracting the times the home team won by 1. So what's left over is the visitor wins. And the total games won, this is just part of the calculation we're doing here. And then we're going to get the overall wins, which is the home wins plus the visitor wins, and then the total games. And then this is how we calculate the win rate for each team. Okay, so we said the overall wins of a team divided by the team's total games. And then we create a new data frame to store the features for each of the teams. So the average points scored, the average points allowed, and the win rate. So this has all the team features. Then I reset the index here, which is what this does. It changed the index so that it's again 0, 1, 2, 3, 4. It was out of order. And then I renamed the column that was home to team, so that when we're referring to a team, doesn't say home, it's just referring to the team. And then this prints out the first 5 pieces of data from our data frame. So as you can see, it's these 5 teams: average points scored, allowed, and win rate. Great. So then now we're going to check out the upcoming games. I just wanted to show this piece of data. These are the next 5 games that are coming. And then we're going to go over to calculating the defensive features. So again, we are going to get 3 defensive features, at least to begin with. And that is the average points defended, which is again the same as average points allowed. That was my mistake. We have the average conceded plays. So a play is considered successful, as you can see here, for the offense if it results in a touchdown or not. If the defense concedes a play, then they didn't create a turnover. You know what I'm saying? So we're trying to look for when a team created a turnover, right? So we create this column called successful play, and then if a team gets a touchdown, or if it's not an interception and not a fumble, then that's considered a successful play. And obviously as a defense, we want to limit the number of successful plays that the offense gets for the other team. So then here we're just getting the average successful plays from the home team, average successful plays from the visiting team, and then the overall average successful plays. And then the third feature that we're going to calculate is the average forced turnovers. So we're just going to create a column called turnover, and then we're just going to keep track of all the plays that resulted in turnovers. So an interception or a fumble. So it's just kind of the inverse of the other one, the conceded plays. So maybe thinking about it now, we probably wouldn't need both of those. We could have just kept track of the forced turnovers. But yeah. So then we're going to calculate the average rate of forced turnovers, the average rate of turnovers forced when playing as visitor and home, and then the overall average. So then we're going to create a new data frame with this data. These are the team features, but the defensive side, same thing we did before. And then we're going to combine into the features that we just created for the offense to the features we created for the defense, and on the team name, obviously. And then we're going to print those first 5 out. So now, as you can see, we have those 3 different features for each. Awesome. So then now I decided that I wanted to add a few more offensive features to hopefully to make the model learn what makes a team win and lose a little bit better. So here we have the average yards per play. I calculated that for each home and visiting team. And then we have the average total yards per game, the average completion rate, pass completion rate, and the average touchdowns per game, and the average rush success rate. So it's just more data that's hopefully going to make our model more successful. So we create the data frame with the new features, and then we're going to combine them with the features that we already had, right? Team features combined, we merge it. And we show the first 5. Now we can see that this thing gets even longer. Cool. Now we're going to do the same thing for the defensive side of the ball. I'm just going to quickly run through what we did. It was yards allowed per play, total yards allowed per game. You can see that it's the same sort of 3 lines of code that we have. So, you know, again, this is available to you, so feel free to copy it if you want to. But it's just, again, getting the home stuff, grouping it by the home team, and then, you know, calculating the average. In case you know how to calculate average, it's total divided by size. And then we get the rush success allowed rate, and then creating a data frame for the new features, and then merging them with the existing combined features. So we're going to have a really, really big data frame at this point. This is the whole thing of all 32 teams. And we're going to have all these different features, all this different data on each team. Okay. Then here we're going to encode the upcoming games with features. So essentially what we're doing is we're taking the home team and we're going to grab all of its data features that we just calculated. We're going to bring it over into our data frame, and then we're going to do the same thing for the visitor team. So if you look at this data here, we have the home team, which is Chicago, and then we have all this data. As you can see, it has underscore home attached to it. And this is all their data for these metrics. And then we're going to further along in this data frame have the same thing for the visiting team. And this is for the visiting team, which was Washington. So that way we have all that data right there on that row for each matchup. But then what we do here is we get the difference between the average points scored for each team. So how many more or less points does Chicago score on average than Washington? And we do that same deal for all the different teams and matchups here. And this is hopefully, as I kind of wrote here, this hopefully will make our model a little bit more successful, a little bit better in understanding the differences between these two teams. And even thinking about it logically, like if a team has a higher average point score than another team, likely they're going to score more points in this game as well. Obviously, we know that it's not as simple as that. It can be as complicated as, you know, the mentality of one team playing against another team, a team always playing tough against another team, like Cincinnati always playing really tough against the Chiefs, things like that. But, you know, this is kind of like a good starting point, I think. And I'm not an expert, by the way. This is like something I kind of done in my free time with the help of, you know, what I know, ChatGPT, asking questions and stuff. So there's definitely room for improvement, but I think this is a good place to start if you want to get into something like this. And I just wanted to, you know, show you how to do it. So now we're going to prepare the training data. So just like how we got the differences between the matchups for each team for the upcoming schedule, which we're going to predict, we're going to do the same thing for the training data that we are going to use to train the model. So essentially, we're just kind of getting the difference between all of these different matchups, these potential matchups in our training data. So, you know, the Eagles versus the Chiefs, what is the difference for that matchup when they're home and visiting, and when the Chiefs are home and the Eagles are visiting? And we do that same thing for all of the teams. So then we have all this data that we can use to train our model. So then we're going to here check out just like the first 5 pieces of data for our training. And you're going to notice that this data is the same. And there's a reason for that. And a reason that actually could probably be adjusted by you if you find that this is not the best for you in the future. But in our play-by-play data, that play-by-play data, obviously, we're going to have however many plays are part of a single game. So, you know, a pass, a run, or whatever. This average points allowed and scored and all that stuff is referring to that matchup. So it's referring to the matchup as a whole. It's not referring to each individual play of the game. So it's kind of a copy. There's a copy of this data for each play that refers to the whole game. You know what I'm saying? So kind of like how if we had a final score attached to this data, it would show the final score on each row of the data because the final score is the final score. It ends up becoming sort of duplicate data. So there's definitely got to be a better way to do this. But again, this is what we got here. And, you know, if you're better than me at this, then feel free to do it in a way that makes more sense to you. We can check out the shape. So we have 50,000 records. And this is because we have play-by-play data for all of 2022 and 2023. It's a lot of plays. Okay. So then now is when we're going to train the model. First thing we're going to do is import these libraries that we need, the logistic regression and the cross-validation score. We're going to end up getting a probability of a team winning instead of a classification that's binary of win or losing. We create the logistic regression model here. We set it to 1,000 iterations. And then we're going to evaluate the model's performance using cross-validation. So cross-validation, if you don't know what it is a way of sort of putting data in buckets so that it can learn from each different bucket. And I'll explain a little bit more. So if, for example, we do a training test data split, so that we're going to train the model on 90% of the data. It's going to learn from all this data. And then we're going to test the model on 10% of the data. So let's say we take the first 90% to train it, and then the final 10% to test and see how accurate were we. And we also, with our test data, we know who won and who lost. This isn't the prediction for the upcoming games. This is based on data that we already have, where we already know who won. So we tested, let's say that we get a 70% accuracy on our test data, meaning that we guessed correctly or predicted correctly on 70% of the games on that test data. That's great, but it's even better, and this is what cross-validation is, if we move that 10%, let's say, to the front of the data. So let's say now we're testing, we do a fresh training. We test the first 10% of the data and train on the final 90% of the data. That way the data is able to predict a new set of data. Or the model is able to predict from a new set of data. And let's say that one was 50%, and then we move that over, and it's 80%, and then we get the average of all those accuracies, and then that ends up becoming the cross-validation score of our model. So we can run that here, and we're going to have an error here, and this is because that we have a few pieces of data that are not a number. I'm not totally sure about what it is, but I'm pretty sure it has to do with there being certain matchups that don't occur every year in the NFL. So as you know, sometimes teams don't play for like a year or a couple years or whatever, depending on what conference they're in and stuff. So there might be games that are happening in the 2023 upcoming schedule that haven't happened, at least in the data that we're training this on. It could also just be that there is some not a number values in the data that I pulled in. I didn't check the data beforehand. This was the first of me checking it, which I probably should have, but in this case, when I check to see how many not a number values there's 3,288. So that is, a small percentage of our data. It actually is 6.5% of our total training data. So, in a more professional setting, you might want to go through and see what are these empty sets of data and, what's going on there. I decided just to exclude those pieces of data. That's again, it's not the most professional way. I'm not the most professional guy with this, but this is what I did. And it worked for me. So anyway, I exclude those pieces of data. Now I have 47,000 pieces of data with our 16 feature columns. Now let's go back to that cross-validation that we were just talking about. So we do that and we get an average accuracy of 70.8% from all those different buckets that we created. And by the way, those buckets, when we set CV to equal to 5, that creates 5 different cross-validation buckets, 20% each. And then it keeps kind of shifting that over to test with. So cool. That's a pretty good score. That's a pretty good accuracy. So now we're going to actually start our prediction for our upcoming schedule. So we're going to fit the model here. This is what trains it. We put the training data and then the labels. So the data is just all the features, and the labels are if the team won or if the team lost. Okay. And then we're going to make our predictions. So here we say we're going to create a data frame. We're going to use the logistic regression model. We say .predict probability. That's what this is. And then we're going to pass in all of the different upcoming games. And we obviously encoded them into this upcoming encoded final data frame. And it goes based again on the difference. So then we run this. We run the probabilities, or we're printing out what we got. And now we have here the probabilities of each team winning and losing. So we're going to take the upcoming game probabilities and grab the second column of it and that's going to be the probability of the home team winning. We're then going to take that data, that probability, and put it into our old data frame here that was just of the games. And then we're going to get those predictions, and then we're going to sort them in descending order of the home win probability. So if we run this and look at it, we can see that in this case, they gave Philly a 95% chance of beating LA. They gave Cincinnati a 85% chance of beating Arizona. And if you go through and check these, this ended up being about 50. It was 50% right, actually. I believe it got 7 out of 14 games, if I'm doing the math right, of the games correctly. So, you know, it's not the best. I would have liked it to be better for this week. And I think a big part of that is bringing in the 2022 data. But the upside is that if you do it just with the 2023 data, I think it could be even more accurate. Just for the sake of checking, I'm going to run it again here without the 2022 data, just with the 2023 data. And I changed this line here to do that. So all data, instead of concatenating this, I just leave it straight up with the 2023 data. I'm going to run that. I'm going to run all these again. Okay, so now we only have 12,000 pieces of data. Awesome. And with this, we don't actually have an error because we're only taking in this year's data, which is cool. Our cross-validation on just 2023 is 75% accurate. And in this case, we have the same probability for Philly. We have a higher probability for KC. We have a higher probability for Green Bay. We have a higher probability for the Saints, and they did win. So when I ran this with the 2022 data, I got 7 out of the 14 games correct. But running it again without the 2022 data, just the 2023 data, I ended up getting 9 out of the 14 games correct, which you can check here for yourself. So that's 64% correct, which I just calculated on my phone. So that's pretty great. That's pretty awesome. It's better than just a random selection. It's better than 50%, which is good. That's what I wanted to see. And it could definitely be made much better by one of you guys. I'm sure some of you guys are much smarter than me, much better than me at this stuff. So have fun with it. And if you're new and you're like kind of a newbie to this, you could probably have fun with this as well. That's it for this tutorial. I hope you liked it. Subscribe and like the video if you enjoyed it. And I will have more tutorials for different things coming up for you. Comment, let me know what type of thing you'd like me to make a tutorial on, and I'll see if I can do it. All right, I'll see you later.